Hello and welcome to the next lecture of Object-Oriented Programming. Before we continue, I want to say a few words about an extra task. Unfortunately, I still haven't received a good solution. All of them were partial. So I think that it's better to give you some hints about how to do that. And I think that I still wanted for you to complete this task. So I know that it is complicated, it's true, but I want you to try. As I see that some of you have decided to work with it, I just want to give you some hints on how to do that. So mainly the part of solution, the easiest part is how to replace basic instructions on C syntax to something that doesn't have letters. Firstly, in C, you can use global variables without declaring a type. It will be by default an int, so you can declare something like ABC, so 1, 2, 3 equals 5. And in global scope, it will be an integer value with a value of 5. So also you can use any names with underscore, for example, and any numbers. So the last thing that you will do in your code is replacing your names with some kind of this stuff. So it's the most easy part. Secondly, can also use the same way arrays like this. Also, it will work. Next, you can use two notations for numbers. So you can use decimal like this. You can't use hex. It's without because you need x here. It's bad. But you can use octal, something like this. It will be 8, as you see. It's an octal. Next, you can use strings if you wish with the codes like this. Also, sorry, as an octal notation, but also you can use strings like this in decimal notation. So it will take you some time to translate your strings with a little endian like this, but it will work. It's not that hard. Next, what else you can do? How to replace if constructions? It's easy. You can use question mark like 1, 2, 3 from 5 from 3.5 question mark a something like this. So if else it will work. For return, you just can declare function like 1, 2, 3, 1, 2, 5, 1, 2 plus equal 5, and the result of any computation will be placed in RIX or EAX register, which also the same that will be returned. So it will return the result of this operation. So it's also fine. No return required. It's okay. What's next? For arguments, as far as I remember, you can pass arguments like this. So you can declare nor 1, 2. As far as I remember, it have to work, but if not, you can use always global scope. And to pass arguments without declaration in C, it's also possible. So if you declare something like this, you still can pass arguments like 1, 2, and it will be called. It's okay. Next, how to replace loops for or while, do, I'm sorry, little pause, and continue. Sorry, one, uh, it was a small pause in my description. Okay, how to replace loops? To replace loops, it's easy. You can replace it by recursion. So just call functions, and any loop can be replaced by recursion. So it's okay. Uh, What else have to be mentioned? So I think that the basic instructions I have give you, it's okay to work. The last part is how to print something on the screen. You have to use something like putchar uh, uh, puts printf write file. So any function. The problem is that absolute addresses can be used because, so one way is to remember on first run the address of any of these function, then cast it to a global scope like this. So something like equals put char, and then and another run you can remove that, and you can print this address, put this address here instead of letters, and then run it like this. Int, oh sorry, something like this, and just call it with 5, something like this. Just call. So here I'm taking the global variable, cast it to a function pointer, and then call it. So also can be worked, but it's not due to ASLR. So ASLR will make this address different from run to run. So it's not good. The key to, so it's correct for all this function. So the key for solution will be to find address of any of this function in dynamic. What you can do is to find them in so most of them are exportable from DLLs, so it will be loaded some DLL load, and most of them will be loaded. So you need to find, so Windows will load all the DLLs you required in memory before your application gets executed in main. So the key option is to find this address. How to do that? Again, um, I'll give you a small hint on where to start, but all the things of working on this process you have to be done by yourself. It's important because most of these techniques are used by a lot of different malware, and you have to know how to do that, how to see it, and how it works. So how it works is on your particular case, you will get something like this. You can declare something like 1, 2, 3 as a 5 as a function, and like 0. So you need some function to get a pointer on that. You need some address. Uh, so this will be address of 1 to 5. Next, 1 to 3 will be a global variable that will track on current address of your function. And now you have to start looking for the base of your module, your exe, as a portable executable format. Then go to, so from this address, you can find the base of portable executable, current base. Next, you can find the export symbol or import symbols section. Then in import you will find all your required libraries, and in library you can find export table, and there you can find by name a search for particular function. So you have to find the correct library for those functions and another library for this. For write file, for example, the kernel32.dll, which will be always presented. Those guys are from MSICRT 140, I think, or 50 DLL that not presented in all systems, but you can use that. It doesn't really care. ARM doesn't really care, so it's okay. So this is a hint on how to start to do that. Go ahead. So it will take you some code, some for loops, some extra stuff to do, but it's possible. So go ahead. I'll give you one more week, and with those hints, I hope you will finally get the solution. Okay. Uh, Now let's get back to our work with the code. So I think that it's important to uh, go back to code, and I think that the practice is the key part. So previous time we have taken the example that we had and split it to basic parts. Now I want to start to wrap all this stuff in, go through the code and make it more object-oriented view. So using some classes, virtual stuff, and all these things. So what we got? We got an algorithm. So I think that it's better to start from a couple things. Uh, where I am. So let me make some to-do list. Uh, First, what I want to do is go through the code and fix styling. Maybe some renaming. Like this is pretty bad. Secondly, after that, we will see all the code that we have and what we can do with that and how to split that. So next will be some uh, structure or like class diagram that will be a sketch um, diagram that will show the structure that we will try to build. Next, we will refactor all things to object oriented way. Object oriented way. So this is how we'll do this. This time I'll try to show you more like ways how things done in object oriented approach. So let's start from going through the code and fix it. So what we have split it all these things in multiple uh, files. Each file has its own goal. We even get a goal description. So let's start from basic. So we got an algorithm library. We got a gameplay, very simple so far. We have a graphics library that does some things from put pixel to drawing. It uses the algorithm library and rendering engine as a basic stuff that renders all things on the screen. So even here, we can start from doing some diagram, which will be a package diagram. Uh, so we got multiple packages over here. Package not always binary. It may be some file, some uh, anything actually that starts from. So here we have like 5 files, which definitely can be presented as a package in a package diagram. So it's some kind of container for classes, for types, and it's better to show some dependencies between packages. So algorithm library. Okay, what we got? We got algorithm library one package. Second package will be rendering engine. Rendering engine. We got graphics library. Graphics library. We got a gameplay. Gameplay. And we got main. Main. So what dependencies do we have? So main actually go only to the gameplay. So it depends only on gameplay. Not this. Depends, yes. From here, come on. Depends, yeah. What we need is, oh, how it works. Ah, yeah, here we are. So we got something for, what's it? Containment. It's not containment, sorry. How it works. Why it's containment? I just need dependency. Oh, those limitations on, okay, let's do this. Okay. Can I change this? For that? No, no. Come on. Can I copy, open, reverse? Why it's not working? My God. Ah, yeah, because it's a class diagram. Okay, let's create a new one. In class diagram, we can use packages, but it's okay. It's a package class, package color, package diagram. Yeah, package diagram. Okay, I hope here it's containment, anchor, dependency. That is what we need. Okay, sorry, let's start from beginning. We got a graphics library. We got algorithm library. Algorithm library. We got main. We got gameplay and rendering engine. Rendering engine. 1, 2, 3, 4, 5. Yeah, got. Okay, awesome. So this is dependency from main to gameplay. Let's look at gameplay code, what it depends on. So basically it depends on graphics library. We can see that fix image clean, it's definitely from graphics library. Then it depends on rendering engine. Okay, so let's add this for graphics library and for rendering engine. And we can see that a rendering engine doesn't have to be dependent on a graphics library. I hope it's not. Where it is, render, it's basic, it's not that. Where it is, where the actual render happens, let's look. It's texture, draw, sprite manager, draw, frame buffer, which is this, update, and it doesn't. Yes, here is just bits, so rendering engine doesn't depend on graphics library. Graphics library also doesn't depend on rendering engine, simply because graphics library, so we got exact this dependency. And algorithm library, uh, graphics library depend on algorithm library because it uses the Bresenham and all this stuff. So graphics library depend on algorithm. So this is how this is dependencies from our package. It looks pretty nice. It's not that hard over here to look at those dependencies. So this is good enough. I think that gameplay may depend on something else, or it can be split it. But so far so good. Uh, so let's go through the slide. So basic idea is that main. So this dependency diagram also give us ability to look at how can we use the where it is encapsulation stuff. Where is encapsulation metaphor? Yeah, encapsulation. So how we can use encapsulation? Encapsulation means that we hide details of implementation inside behind some interface. The nice example is here. If we look at main, we have only Arkanoid run, and from this point of view, from this module, which is very, very simple, it's easy, and it doesn't actually show us exact internals of Arkanoid run. What happens inside? We just know that we can run it. We can add some behavior before, after, some checks, some maybe logging, and it doesn't depend on how actually Arkanoid run happens inside. But inside it happens a lot of things. It starts doing some rendering, it do some handling of input and so on. So this is encapsulation. We see only interface that tells us that we can call this function that return an error code and nothing more. So without arguments, and it will do the magic. So it means, and actually this uh, ability of encapsulation of hiding details is exactly tightly connected with the dependency diagram, where we can see that main depends on gameplay and nothing else. So we don't care about how gameplay inside. Main doesn't even know that it uses graphics library and rendering engine, because we have only one arrow here that gives us dependency. And this is the uh, edge where we can give some internals from gameplay to main and nothing more. So this is a good design when main doesn't care about what gameplay happens. Actually, personally, I really like main stuffs like this. It tells us that this has no dependencies extra, so we can use this whole Arkanoid game as a model somewhere else. Maybe it may be a part of very complicated option. It may be, let's say, a part of spreaded, or it may be run on mainframe and have a multiple instances, whatever. So we can run it multiple times in different threads, and doesn't really care because we have only this simple interface. And what main how it do this is very nice, that we can have no idea how it works inside from this point of view, and we can use it as many times as we want, as many options that we want, and so on. So it's really, really important to keep as much. This is an ideal idea. Ideal when we have nothing and no arguments, just run and nothing more. But you know that actually it's not that absolutely correct that I'm saying. It's not the only interface, because we have to have a dependency on the DirectX. It may have some global options that restrict us to run it multiple times. It has a while one inside. So it has some more abilities. But the ideal way is just to make any option or any application that you try to create like this. Here in main, basically you have to parse arguments, and actual application just don't really care how arguments come to it. Maybe it's from command line, maybe it's from JSON file, from XML, from a network, doesn't matter. The actual uh, logic of your application doesn't have to know about where all settings come from. This is just an example. The same encapsulation, like how does arguments come to here? We don't care. And we can continue and look here and see that we have dependencies on rendering engine, like a render base. And you see we have structure rendering properties, like a full screen or not, width and height of window to create, and multiple callbacks. It's function pointers. You see it's function pointer. And this is how our rendering engine depends and sees the outside world. So basically, now we say here that rendering engine itself doesn't care about how it actually work. We don't care whether it is direct text or not. We are not using any direct text structure here. We have only byte star as a buffer. And we can use helper stuff from graphics library to render on the screen like bar. It's a filled rectangle as a bar. So what we can see here is also that exact rendering engine don't care how do we handle keys, mouth move, update, and how it will happen inside. What we can do here, we can modify the basic cycle of render base, which is basically while one, which renders every frame, and how many runs per second we can get. It will be our FPS value, frames per second. So what actually rendering engine, a typical rendering engine does, it does while one and render each new frame, new frame, new frame, new frame, and so on. And on each frame, it will do some handling on input and just update like some animation updates, movements, and so on. And any game that you see right now, in most cases, in the core inside, it's actually the while one that does like this. It does something on each frame, and the whole optimization process is to reduce this time as much as we can. This is how we can optimize FPS in any modern game. It's still the same. So we are doing our own, and we see these dependencies. So this is what we got. Let's start to do some refactoring and going through the code, and firstly do some alignment and renaming. So let's start from a main. Over here, we have awesome Arkanoid as a name. We don't have an awesome Arkanoid name as a name of our. We got still our OP example, which is not maybe nice. So let's change it and rename our project as a awesome Arkanoid. We can do it like this. It's now awesome Arkanoid. Now we can look at where we are, so we can open containing folder, and still the folder is named OP example one, and here we are. So we have a bunch of not very nicely look files. So let's look in our. I forgot to check our Git option. So what we got, refactoring stage, current tree. Yeah, we have already split it. Fine. Let's go ahead and do renaming of directory. How we can do that? We can unload this, unload project. Yes, save. Now we can reload. Sorry, we can remove this. Yes, we can remove. It's just a link, so we can now rename awesome Arkanoid. Sorry, yeah, it's an awesome Arkanoid. We can rename these files as an awesome Arkanoid, awesome Arkanoid, awesome Arkanoid. Now we can add existing project, which is awesome Arkanoid. We got some problem that it doesn't. Oh no, we got that. Awesome, awesome. Nothing wrong. It works. Now we got everything renamed. We can make it as a startup. To start it, every time I press F5, and now uh, let's go through the code. So awesome Arkanoid.h, and talking about the uh, dependency and talking about the encapsulation, we can split our header file to let uh, modules no less than required. So right now we have one header file which tells everything about our internals. If we look at main, it includes everything about directX, about internal structures, everything like this. We don't need this. Actually, all we need for main is run and nothing else. So far, let's split our header file on the multiple files to get all the power of encapsulation. So we got a couple copies right now. We will have our Arkanoid public. Then we have our name. So let's say we have a private, which will be a basic. Then we have a public, not a public, just a name for basic stuff. Private will be the basic. This will be public. And now for modules. So we will got gameplay. We can even do like this, gameplay.h. It will be a graphics library .h. It will be a rendering engine .h. What else? Algorithm library. Sorry, it will be algorithm library.h. Algorithm library. Now each module presents as a combination of C++ and H file, which is normal for C++ project. So now let's add all this stuff, and I'll explain you why do we have so much header files. Add private, yeah. So this will be a private stuff, which is general for all modules. What we need is a Windows H, maybe Math H. Goal is all basic defini definitions, which will be shared, that are shared between modules. Maybe some settings, some global settings that are basic constants, error codes, and all these things. So far, we just need only headers and nothing else, so we can actually remove this in total. So we don't need nothing more. Next, this will be a public. This is all public definition declarations for use for use all public declarations. So it starts from Arkanoid. Sorry, awesome Arkanoid private. Awesome Arkanoid private.h. Here we are. And what we need only a one function declaration for run over here. So this will be the best. Now we'll look at main. This should be fine. Now let's go through the next module, which is a gameplay. And a gameplay over here needs only stuff that, so it's only a gameplay.h. And now open the gameplay.h, which will start gameplay declarations. And this is where we'll see the dependency makes happen. So we see that gameplay depends on graphics library and rendering engine. So here we can include as default a private, which is a basic declaration. Now we can include rendering engine. We need it, and we need graphics library. Graphics library. Actually, we don't have any personal and own. Let's look what we have. It's from graphics library. This is from algorithm. This is we don't need this. It will be our internal stuff. We can keep this. It's not very required, so we can actually remove this too. So play. This is our gameplay H. Well, now graphics library. It depends on only on algorithm library. So we need only algorithm library and no more. So it's graphics library declarations. And now what we see, this is definitely from graphics library. This is from algorithm library. We don't need this. It's for rendering engine. We don't need this. It's from graphics library. We need this. It's our own declarations. Yes. It's algorithm. We don't need this. It's rendering. We don't need this. It's rendering. It's a gameplay. We don't need. Actually, we have forgot this for gameplay. Sorry. It's for gameplay. Gameplay H. So it's algorithm library. We don't need this. No globals. Functions. Yes, we got graphics library, rendering engine, no. Algorithm, no. Gameplay, no. This is our graphics library. Now algorithm library, which is private and oh, my bad, I have mistaken. Oh, you see, it's not good to name something very similar like algorithm library, awesome Arconaut. It's easy to be confused. It's not good. So, our Arconoid algorithm. Now, our algorithm library. What we got? What we got? Again, we need like in a gameplay something like this. Oh, sorry. It's for algorithm library declarations. It doesn't depend on anything, so no includes here. Check. Yes, algorithm library doesn't depend on anything. So it doesn't need a graphics library, it needs algorithm. Rendering, no. Graphics, no. Algorithm, yes. Rendering, no. It's from algorithm. For some reason, it uses, yes, uses color. Okay. Looks like we have a dependency from algorithm to graphics. We'll check that. Globals, we don't need this. So we don't know rest. T image. Okay, we'll look at this. Okay, functions. We'll try to keep this schema and maybe do some refactoring and changes to make this work. Okay, now rendering engine. It doesn't depend on anything, so again, the same declaration as for here, here, as for rendering engine. Now, no graphics, no algorithm, yes for rendering. Rendering, 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 rendering. Awesome. Now let's try to build this. I think we'll got some errors. Yeah, because we haven't fixed the C++. It's algorithm library. It's algorithm library. Gameplay will be a gameplay. Graphics library will be a graphics library. Main will be just this, and this will be a rendering engine. Also, due to the encapsulation, we put includes here, and nobody outside the rendering engine will no idea how is implemented through the DirectX or not. Okay, let's build it. Okay, we got some errors here. Let's look. We got some problem. It's a Murphy. It's a algorithm problem. So we got a fixed color, which is color, 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 color. So it looks like we have some tab on color problem. What we used, let's look at how color, 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 fx color, fx color, fx image, fx image, fx image, fx image. It looks like handle, or maybe we got pb set pix. Oh yeah, it looks like a handle. Okay, let's now do some encapsulation. So right now we have a problem that on the schema right here we have a dependency only from graphics library to algorithm library, but algorithm library actually depends on graphics library like this. Uh, links like this when we have a two-way dependency is not very nice. Uh, Honestly, it means that this is one package, not two, because they have links from A to B and from B to A. Let's try to remove this dependency. Actually, algorithm library right now truly don't care about how what colors are used. We see that we use fximage set pixel, uh, and this also another dependency from library. So we see that Murphy line will actually call function that put pixel somewhere, and it does like call, and we don't want to depend on that. What we want is basically we need to set pixel two coordinates, which is internal def_pt. It's not nice name, but it's still okay. And a color. And this is an image. And actually, this algorithm don't really care about image at all. Let's look that we have no dependency. Yeah. So let's remove this dependency by tweaking with these types. So far without renaming, but we want this image to be replaced on void star. it will be just a handle, so some special pointer that we set up and don't really care uh, uh, which exactly it is. Fx color also can be replaced on something that can be used. So this is a good idea for global private variable. Like let's do type def, and as an unsigned int, as a color, as a it will be a color representation as 4 bytes. Yes, it's a color representation. Assigned int always will be a 4 byte. It doesn't matter on what bits we have. Now we can use it in algorithm library and replace that as a color, and now let's build it again. We got an algorithm library with the problems still got. Blah blah blah. Here we are. This is a color. This is void. Void means just some handle. Doesn't really care. Let's look. Now we have a problem with a fixed set pixel still, and over here also set pixel. We are calling the same stuff. So to remove this dependency, we can do like this. We can declare. Let's look at graphics library, and where is the set pixel? Set pixel like this. Let's declare global. Let's do a type def. It will be a color. It will be int x and y, and void star handle, some handle, and it will be let it be int, and it will be algorithm set pixel. So now we can declare global like this. Set pixel. Sorry, pixel. Stern. Now we can declare it in the algorithm library. Not an extern equals null. And somebody else have to set this set pixel function. Let's call it like this. Set pixel function. Now let's replace h on this current document. Replace, yes. Now we got no problems. And just one minor thing, I want to add some if constructions to check. So let's define, let's do a little bit more accurate way. Let's name it as a do set pixel. Let's declare this. Let's go and declare this. Why that? Just not to do if every time, just do it one time, just to wrap it in one function. So if it's not null, we can call it with the appropriate arguments. Return p handle x color and return 0, or let's say -1. So now we can replace calls like this by this. Yes. And we got problems only in two places. Here we are. 1, 2, 3. Now it should work, at least build, but I think that we will got some problem. Yeah. Undeclared identifier. Nice. Global screen. Nice. So it's in rendering engine. I think that we have removed some stuff from rendering. Yeah. It looks like from a gameplay, but it's not. Yeah, we have to move this, or let's say split it, like running. And move it to rendering engine.h. Let's check. Can't convert. Yeah, that's true. Now we can set in the gameplay library. Do we have any graphics library? Graphics library. Let's look at dependency and where we can set the algorithm library. Yeah, in graphics library. Nice. Graphics library. We don't have any like create, destroy. Okay, let's add some init function. Fx init library. No more here. What we can do is we can look at algorithm library, take this stuff and assign a function RGB like this. We are not casting this. This is a color that expects, but it so here we have a problem that we can't cast two different names because we have a fixed image int fx color, and actually it's not converted like this, so we can pass and do some cast over here, but it's not that nice. Maybe it's better to prepare a function so we can actually do some function like this. Sorry, I can do a graphics library and do some extra converting, just not a direct conversion, but with a nice fix set pixel set pixel. We can do like this, which actually return, and here we can cast it to int, or just ignore return fx. Okay, now we can cast this to from handle, sorry, handle. Now we can int okay. To do a correct conversion, c dot value equals color, and here we are at c, just to make the correct conversion without any extra casting, because maybe we'll decide to change a fixed color for something more than just a union, so it will look better. Now we have to export it to graphics library. and call it on our gameplay due to this dependency. So gameplay do like this. So we can't assign the pointer to. So we have done add a function pointer as a put pixel for graph algorithm library, which really don't care how it will do. It's just an algorithm that do it in correct way, in correct order. So even not for colors, just in correct order. That's why we just set a function pointer and set it in graphics library. We can't do it in gameplay because graphics library depend on algorithm. If we will do it in gameplay, we'll add extra dependency link, which is not nice. But now still graphics library have to be initialized. So this function that set this pointer have to be called from a gameplay. So we can do a gameplay. We have a init somewhere like here, and we can do a init. I think that it now have to be builded. Failed. Can't convert its color to color. Nice. There we are. It's yeah. Fix color dot value to a color like this. Must return a value. Okay. Return return fx. Okay. Build. Awesome. Let's run it and check that everything works fine. Awesome. Now let's do still some styling conversion. So right now we got correct schema. We got splitted headers. Now let's go through all files and make them look better. First, uh, let's start from algorithm library. I don't like these names, Murphy, Murphy, Gray. So it's two different algorithms. So I think that it's better to remove tabs, do some rearrangement, and do some renaming. So firstly, let's rename this to uh, algo. So let's create some syntax stuff to see that this is from algorithm library. Uh, we can do as a al as a some simple sorry as a suffix. Also, we can do small. So what we have algorithm library, Arkanoid, AA, two letters A, not very nice, gameplay, graphics library, and rendering engine. Let's create some suffix in a lowercase. Let's say it will be LG, which means algorithm, stands for algorithm, LG Murphy. So right now I'm designing some syntax style. It doesn't really naming convention. You will see how you see right now we don't have any naming conversion. This camel case, this lowercase, this very bad. So let's try to rename everything to look better. So I decided to add ALG and three letters acronym for all these modules. So it will be an algorithm. Uh, so it will be a graphics algorithm. Let's maybe rename it as a firstly let's commit before any changes. So renaming modules and fix dependency. Yeah, before any changes. Awesome. Commit. Now, maybe it's not good names for modules. Let's say rendering engine. It's okay, it renders. True. Graphics library. It's really a graphics library that do some image drawing. We can name it a draw library. And algorithm library is not also nice. Maybe I don't like that. It is a letter for Arkanoid. Oh, it's better to do more distinguished. Let's so the gameplay itself it can be named as Arkanoid. Uh, just an Arkanoid, not some just an Arkanoid or Arkanoid game. Arkanoid game, yeah. Let's name it as an Arkanoid game. Graphics library will be image draw image library image library is something that has a set of images. No, drawing image drawing, let's say, or also it can be a canvas 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 draw this, draw that. It's a canvas. Yes, it's a canvas. Arkanoid game canvas. Algorithm will be draw algorithm drawing algorithms. Also, Arkanoid it's a public. It's a private canvas rendering engine. Let's call it just rendering. Rendering. Canvas rendering drawing Arkanoid. Okay, drawing Arkanoid canvas rendering. Let's rename the same. So algorithm will be drawing. It will be Arkanoid. It will be canvas. It will be a rendering. Now let's look at includes. So let's rename Arkanoid H. Let's call it still game. It's better to call it Arkanoid game. It will be an awesome Arkanoid. Okay. It will be I don't like these two long names, so it will be Arkanoid internal dot h or internal private. No. Uh, basics private h. Basics private h. Or let's say basics h. Okay, let's call it like this. Drawing. No, sorry, drawing. It will be basics. Arkanoid will be basics. So the naming is very important. So it's better to a color. It will be a color. Okay, it will be basics. It's rendering. H graphics library is a canvas. H canvas is basics. Also, we can see that basics is a lowercase, all others a camel case, which also makes it different to mention that it's a drawing .h rendering basics. Okay, it will be drawing.h. It will be arcanoid.h. Sorry. I'm sorry, just a second. Just a simple pause. So let's continue. So right now, canvas main will be awesome arcanoid is okay. It's a public stuff. It's a rendering. Now let's rebuild. Arcanoid. It's not an Arcanoid. Arcanoid game. Yes, sorry, game. Let's rebuild. Okay, let's now commit our changes. More renaming. Commit. Now we can change the schema. It now main. Now it's a Arcanoid game. Its graphics library now is a canvas. Now it's a drawing. It's a rendering. Sorry. Awesome. Now, now let's continue to work with drawing. Now we can rename this as drawing Murphy context. It's a type name for context. Let's rename. Oh no, sorry, current project. Yeah, yes. Let's look at this. It's a color context. Okay, so this is dress. Okay, it's drawing dress. Where it works. Okay, let's look. It's a Bresenham context. Okay, let's call it Murphy. It's Murphy. Okay, two different algorithms, so we can rename this in the current project drawing Bresenham. How it's like Bresenham context. Replace. Yes. Okay. Now, looks better. Now we can do this and rename it to drawing. Drawing wing set pixel. Awesome. Yes. Okay. This will be a drawing set pixel function. Yes. This will be a drawing G drawing. Also, it's better to G means global, P means pointer. It's a drawing set pixel function place. Yes. Okay. Clip area code will be drawing clip area code. Okay. No, but I forgot an underscore symbol. Place. Yes. Now let's continue to it's static. We don't need this. We can let's do this. Clip inside. We can replace it. Drawing. Clip inside as a suffix. Clip left. It will be drawing clip left. Yes. Okay. Click right. Click right. Yes. Yes. Okay. Below. Below. Yeah. Above. Above. Some clipping function used somewhere. Okay. I don't like the code like this because it doesn't have any braces and curly braces over here. I don't like the code when it doesn't put without curly braces, simply because this may be some macro that can be translated to multiple lines at some point and may be wrong. So much better to use a rule that never keep code like this, always add curly braces. It will make your life easier if you will do some mistakes at some point. It will be hard to the same here. X1 maybe some replacement, some definition. So I'm doing some style replacement. Else if is okay. Now the same for Y. Now here. Actually, this makes code look a little bit simpler, I think. It's easier to read the structure. So the same for here. Click with border. Click with border with a drawing, click with border. You see that the name of the module makes names for all input stuff. It's easy because when we happen to see the name like this, we'll always know that this is definitely for this module. Let's continue. Double T, no initialization dot D, the same here. Curl braces like this, like this, like this, like this, like this, here. So I'm doing some fixes that I think is making code better. In the same way, I'm looking through the code and looking for algorithm and matching the problems, potential problems somewhere that may be. So DT clip line. So it will be drawing clip line, replace. Yes. Just making code a little bit look easy, so it's better to add some assignment. Always good. Clip fully inside. It looks like a declaration. Yeah, we can replace it like a drawing. Clip fully inside. Using all in uppercase makes us see that this is a macro and pay more attention to this. Drawing clip surely outside. Honestly, doing some renaming and actually we can swap int and drawing swap int place, yes. Double declaration, clip draw, drawing clip, clip draw. Uh, clip drawing, clip no draw. Okay, you see that it looks like the same. This is looks like flags, so we can do like this. It's flags, but this is not flags. It's some right, and this is draw, but names are the same. So let's do drawing draw, draw, uh, clip draw, drawing draw, clip draw. Okay, and this is drawing draw, draw, clip no draw. Place, yes. Okay, Bresenham error will be drawing Bresenham error. Yes. The end of line, end of line, yes. Hypot, drawing, yes. L, R, int, I don't know what is this actually. Okay, now it looks nice. Now let's continue. So what we have here, okay, it's a printf. I don't know, like lines, I like comments like this. So this is okay, 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 okay. You see, it's easier to read, so it's okay to keep like this. Minus, minus. Oh, it looks strange. E, okay, okay. Oh, you see, it's now 1, 2, 3, 4, 5, 6. Now it looks better. Bresenham neat. Okay, so drawing Bresenham. Oh, init. Replace. Yes. Device PT. Let's replace it as a drawing point. Replace. Yes. Okay. Okay. Let's just remove tabs. Actually, we can do like this. File. No, edit. Advanced. Untabify. Select lines. Yes. So where we are, it's a Bresenham. Okay, let's continue. Some assignment. Like this, like this. like this, like this, tabs. Why doesn't tabify this? Okay, like this, like this. Again, we are going through the code and look at it, what we have. It's always nice to do the refactoring like this when you especially trying to use it on your own code, just because you're going through and next time you will get some problem, maybe you will mention, oh, I have seen something like this while I was going through the code, and it will maybe help you to find those bugs. And actually, my personal experience gives us exactly this stuff. Next. Yes. So void over here is required only for C code, not for C++. Actually, differences between C and C++ compilers is very huge, and it's more you work with C and C++ code mixing, the more you see those differences. And so Bresingham is an algorithm that allows us to draw lines using only decimal letters, decimal numbers. It's very fast. So it's Murphy init. Murphy init. Awesome. Yes. Okay. The color. Let's replace it as a. No. PB pointer base. I don't know. PBs. I don't like this. So we will maybe change this. So far, let's rename it p handle. It's a handle. Going Murphy line place. Yes. Why it's not tabified? Edit, advanced, untabify. Why it's not working? So I'll continue to work with the code, keeping comments. So I hope that at least we'll complete this code to the end. It's not that huge. Set pixel. It's comment for here. Can I move this? Something like this. Something like this. Diagonal move. Okay. This part of code looks a little bit better. Okay, white line. White line. Okay. Okay. It's floating. Okay. Oh, a lot of tabs. Why Untabify is not working? Edit, advanced, selected lines, Tabify, selected lines, Untabify, increment, increment. Okay, we can do no, okay, like this, like this. So checking comments. It's better to keep comments, especially for out external code. Maybe sometime when you need to find the bug or do some uh, enhancements. It makes you life easier when you see the comments. This is for internal. This is for oh, this is for this swap. Murphy. Okay. Hope it will not have. We don't have a too huge code. It's just more than half of this file, so almost done. Almost done. Yes, 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 yes. Now, now, it's a comment for loop. Almost done, almost done. Square move. Actually, I don't really know what Murphy Birmingham. I know Murphy and not, so I have no idea why I have added this for some reason. Anyway, let's keep it so far. Maybe we'll require this. Anyway, we will not do more changes with this code. It's just an algorithm that is internal implementation. We keep it as it is without any more changes. We have removed any dependencies from it. And now we can do our external implementation that uses these algorithms at this point. Maybe at some point we will add maybe some free type to draw symbols. Maybe not. Maybe for do meter what it is. Drawing do meter. No idea. Okay, yeah. Some function. I don't like when one single argument is on another line. It looks very strange. Almost done, almost done. Oh, hooray, one more function, almost done. Whoa, whoa. Yeah, do meter. Okay. One last function to do. Okay, let's keep this, I think. Looks nicer. Nice and clean. You know, it's also a good thing to make your code look better. when you see the beauty of the styling of the code, when something is very accurate, it's easy to see. Your eyes are satisfied when see this kind of code. So especially, of course, almost most of these things are very dependent on personality, but the core thing is to make it as one style for the whole project. So if you came to some other project and they already use some particular style, use that. Doesn't try to insist on your own style. It's better to use something that already exists. If you are creating your own project, you can use whatever you want. For example, right now we are doing our own project, so we are doing our style as we wish. So the last thing is to look at the drawing.h. Set pixel is p drawing function. Yeah. One more thing. Let's look at this. I don't think that we need globals. It's of course it's globals. That's no need. Algorithm library. Yes. Yes. Orphe. Yes. Like this. Context globals. Algorithm. We don't need this. We just need G drawing Murphy CTX place. Yes. Okay. Bresenham drawing Bresenham CTX. Yes. Yes. Okay. Yes. Functions like this, like this, and we don't have a set pixel. We have a set pixel. It's in the beginning. We don't need this. Click line, Bresenham, static. We don't need static. Drawing. Awesome. Build. Awesome. So we have some warnings in drawing. Let's fix it. Dot zero. Let's rebuild. I'm looking for removing all warnings. So we have some warnings over here. Conversion from double to float, possible loss of data. With we can add this. Build. Let's rebuild. Warning. So no warning in drawing. So it's okay. Let's check that we have done one file completed. Next, we will continue to work with the canvas next time. Thank you. It's all for today.